Assalamu alaikum, dear student. I am here to deliver my third lecture in applied mechanics. Topic of our today's lecture is measurement. Measurement is basically very basic thing in everyday life. We all are doing measurement at anywhere, any place, at any condition. We are doing measurement. Suppose if you are buying some vegetables or we are buying some other everyday things from different shops, e.g. sugar, oil, then we just demand that give us 1 kg of sugar or give us 1 dozen of bananas or give us 1 meter of cloth. So all these things, 1 kg, 1 meter, 1 dozen, these are standards set for everyday life. So measurement is basically the comparison of thing with the standard quantity. So whenever we are comparing thing with standard quantity, we are doing measurement. Coming towards the basic definition, measurement is the determination of the size or magnitude of some things. Due to measurement, we know that how long, how big, how small, how short thing is. Okay, it gives us magnitude of something. That suppose if a person asks that how far Islamabad is from Peshawar, then we have the calculated amount that we directly says that it's 240 kilometer. From where these 240 kilometer came? Basically it came from the measurement. They measured with their standard quantities, which is kilometer, and how much kilometer came, they add them, multiplied them with number. Okay, suppose it 245 kilometers, so 245 is number and kilometer is unit, and this is the measurement of the total route from Peshawar to Islamabad. So measurement is a process of detecting an unknown physical quantity by using standard quantity. It's the process of detecting unknown physical quantity. We don't know that a book which is in front of us is what are the length of that book which is in front of us. So if we want to find the length of that book, we will take a ruler, a standard ruler, and we will compare that book with that standard ruler, and it will give us some number or some magnitude which will be the measurement of that book. Suppose it gave us 20 centimeter, so it's mean that the book length is 20 centimeter. The unknown physical quantity was the length of book. Required quantity was a ruler. The ruler was a standard quantity. We will compare the length of book with this ruler, which is a standard. So when we compare the length of book with standard, it gave us 20 centimeter. So it's mean that we do measurement with the help of standard quantity, okay, which is ruler, and we compare book with that standard quantity, so it gave us a number and we got our objective, for which purpose we are doing to find. Now what are the units of measurement? For different quantity, different units are used. For liquid we are using liter. For solid things, in most cases we are using kgs. If it's a large number, we are using ton, we are using metric ton, and for liquid we are using cubic meter, cubic feet. Got it? Unit provide specific meaning of magnitude of a substance. Units of measurement provide standard to identify measurement of physical quantity. Basically, unit give us the standard due to which we are able to find out unknown quantity. E.g., for example, if we are going to find mass of unknown quantity, so we will compare it with their standard, which is kg. If you are interested to find the length of an unknown quantity, so we will compare it with the meter. If you are interested to find out time duration, then we will compare it with seconds. We are divided units into two basic groups. One is called fundamental unit and other one is called derived unit. What is fundamental unit? Fundamental unit are those units that can express themselves without the assistance of any other unit. Those units which express themselves alone without the help of any other unit multiplication or division is called fundamental unit. Example of fundamental unit are kg, kilogram. It's a fundamental unit. Why it's a fundamental unit? Because it's independently expressed and cannot be broken down into multiple unit. Kg is a fundamental unit because kg express themselves alone. There is no need to break down, to multiply it or to divide with them, and it's express its value alone. Simply, meter is also a fundamental unit and second is also a fundamental unit. Now, derived unit. What is derived unit? Basically, those units which cannot be expressed in the absence of fundamental units. Simply, derived units are the multiplication or division of fundamental units, and it cannot be expressed without the presence of fundamental unit. If there is no fundamental unit, that it's impossible to there will be a derived unit. Derived unit are basically derived from fundamentals, fundamental unit. That's why we call it derived unit. Suppose we have a unit of force, Newton. It's an example of derived unit because it cannot be expressed in the absence of fundamental units, meter, and can be broken down multiple unit. Newton equal to, if we are finding that what is Newton equal to, that 1 Newton is equal to kg multiplied meter divided by second square. So, the unit of force Newton is the example of a derived unit, and here it shows that 1 Newton is equal to the multiplication of kg with meter and divisible by square of second. Basically, 1 Newton force is that force if we applied force on 1 kg body and it produce acceleration of 1 meter per second square in that body, then this force will be equal to 1 Newton. Now we are going to explain the fundamentals unit. First, of all we are going to explain second. Second is the unit of time. Okay, and it's abbreviated by S. From many years it was defined that if we divide one solar day into 86,400 parts, then one part of it is equal to 1 second. More recently, new standard was adopted to gain greater accuracy to define the second in terms of non-varying or constant physical phenomena. But nowadays second are defined according to new technology and new standard, because second is a fundamental unit and there is no chance that there is no chance to be any fault in this. So according to new standard, this why we regret that 1 by 86,400 parts of a solar day is not equal to second. The reason that scientists told that solar days is getting longer due to very gradual slowing of earth rotation. Scientists says that solar days are getting longer. Why it's longer? Because they shows that the earth rotation is gradually in very small number, it's slowing. After 100 or 1000 years it will change that a nanosecond will change during the earth rotation. But it's as I say earlier that it's a fundamental unit, so we have to be that unit accurate, and there is no doubt in it. That's why scientists define second again. At that time they took cesium atom can be made to vibrate in a very steady way, and this vibration can be radially observed and counted. In 1967, by observing cesium atom and their vibration, in 1967 they redefined atom, and they said that 1 second is equal to the time required to complete 9 Arab 19 crore 26 lakh 31,770 vibration. They redefined unit of time again in 1967. They took cesium atom as a standard because cesium atom vibrate very steady way, and they count the vibration and they find that time required to complete 9 Arab 19 crore 26 lakh 31,770 vibration will be equal to 1 second. Accuracy in the fundamental unit is essential because all measurements are ultimately expressed in terms of fundamental unit. If our fundamental unit is not accurate, then how it is possible that all other calculation will be accurate? That's why accuracy is much important in fundamental units. Now meter. The SI unit for length is meter, abbreviated by M. It was defined in 1791 that if we divide the distance from equator to north pole in 1 crore parts. So one part of that will be equal to 1 meter. If we in 1791, meter was defined that if we divide distance between North Pole and equator into 1 crore, then one part of that 1 crore will be equal to the length of one part of that 1 crore will be equal to 1 meter. This measurement was improved in 1889 by redefining the meter to be the distance between two engraved lines of platinum iridium bar now kept near Paris. They redefined in 1889 and they says that it's the distance between two engraved lines of platinum iridium bar which are kept now in a place near Paris. By 1960, it had become possible to define the meter even more accurately. At this time, they took the wavelength of light. From it, we can also they redefined the meter in 1960 again and says that 16,50,763.373 wavelengths of orange light emitted by krypton atom is equal to 1 meter. But in 1983, they redefined the meter again, and this definition is used nowadays also. At this time, they took greater accuracy, and as the distance of light traveling in vacuum, in 1983 the meter was given its present definition, partly for greater accuracy, and they defined that the distance of light travel in vacuum and 1 by 29 crore 97 lakh 92,458 of a second. How much light travel in 1 by 29 crore 97 lakh 92,458 part of second? That distance will be equal to 1 meter. From it, the sound of light are also exactly measured, and it's known that speed of light travel in 1 second 29 crore 97 lakh 92,458 meter per second. After it, the most important unit and the most used unit in daily life is kg. The SI unit for mass is kilogram, abbreviated kg. It is defined by the mass of platinum iridium cylinder kept with the old meter standard at International Bureau of Weight and Measure near Paris, and exact replica or copies of that were distributed all over the world, and with that standard all over the world are used. One replica of that standard is also present at National Institute of Standard and Technology, NIST, located Gainsborough, Maryland, outside of Washington DC, and other locations around the world. The determination of all other masses can be ultimately traced to a comparison with the standard mass. It's all for today. If you have any question, you can ask me. Okay, take care of yourself. Assalamu alaikum.